Let us find all complex number z such that z minus 2i times z bar equal to 5 plus I. So we want to solve all the complex number z, but we know that any complex number z can be written as z equal to x plus iy, where x comma y are real numbers. Any complex number can be written in this type. That implies we want z bar as well, so conjugate of z equal to x minus iy. So let's replace z and z bar in this equation. So that implies we should write let z equal to this, where x and y are real number. So x plus iy, we are simply writing z as x plus iy minus 2i times z bar is x minus iy equal to 5 plus I. Remember, x and y are real number, so we can a bit simplify this equation and write x plus iy minus 2i times x minus minus plus, so 2y into I square is minus 1, so again minus 2y equal to 5 plus I. Now if two complex numbers are equal, then their real parts should also be equal and also imaginary parts. So we got real part x and 2y and 5 on the right hand side. Therefore, if we compare those two complex numbers, we obtain x minus 2y equal to 5. So real parts are equal. What about imaginary parts? Y minus 2x equal to 1. The coefficient of I is just 1. Next, can we solve for those two equations? So let's rather say, can we solve for x and y from these two equations? Of course, we have two equations and two unknowns, so we can solve. So we got x minus 2y equal to 5 and y minus 2x equal to 1. Okay, let's write this one as equation 1. And from there we can write y equal to 1 plus 2x. Okay, if I write y back here, substituting y into equation 1, then we can solve for x. Let's do it. So substituting y equal to 1 plus 2x in equation 1 we obtain. In equation 1 we have x minus 2y. But instead of y, we will write 1 plus 2x equal to 5 as it is. Can we solve for x? Of course. X minus 2 minus 4x equal to 5. Let's take number to the right hand side and simplify the variable from the left hand side. We got 1 number of x minus 4 number of x, so we will be left out with minus 3 number of x. What about minus 2? If we take it to the right hand side, it will be plus 2. That gives us minus 3x equal to 7. So x equal to minus 7 by 3. Minus 7 by 3. Now we write the value of x in equation 1. By equation 1, x minus 2y equal to 5. So we got x equal to minus 7 by 3, but by equation 1, x minus 2y equal to 5. So we replace x by minus 7 by 3. We simply know the value of x equal to minus 7 by 3. We take once again number to the right hand side. So we obtain minus 2y equal to 5 plus 7 by 3. 5 into 3 is 15. 15 plus 7 by 3 is 22 by 3. So we got 2y equal to 22 by 3. Sorry, minus 2y equal to 22 by 3. So y equal to 22 by 3 into minus 2. We can cancel 2 out, so y equal to minus 11 by 3. Therefore, z equal to x plus iy equal to, we got x equal to minus 7 by 3. So minus 7 by 3 and then minus 11 by 3 times I. And we are done. Z equal to minus 7 by 3 because x equal to minus 7 by 3 and minus 11 by 3 times I.